Good morning, everyone. How's everyone going? We are here in Flex Week for a not structured, but more of a Q&A live stream. And I have with me today Tammy and Tom, two of the tutors. You may have met them depending on whether you're in their tutes or not. Do you want to say hi? Tammy, do you want to say hi?
Oh, hi guys. I'm Tammy. I'm tutoring for two of the tutorials each week. So Tuesdays and Thursdays be tutorials if you're in my tutorial.
Yep.
Hello.
And hi, Tom.
Hello. Yeah, I'm also tutoring two tutorials Tuesday and Thursday as well. I'm also the course admin, so you've probably seen my name popping up occasionally.
Yep. So, today is, it's not structured content because any kind of structured content is stuff that goes into the main lectures. But since we had the time slot, and it's recorded anyway in case anyone watches it or needs to watch it later, we thought we would do something like a Q&A or a... if there aren't questions, Tammy's actually the forum manager for the course, so she knows what questions are being asked the most in the forums, so we can potentially pick out one or two of the questions that people are asking a lot of and do a bit of a code demo here in case, and then that way maybe you can send people to this video as well as forum posts afterwards. So let's open it up to anyone. Oh, I should say also that we're not going to answer any direct assignment questions on stream because that's kind of like, we don't want to plagiarize the assignment ourselves within the subject. But if you can structure your question in the right way and ask about the topics that the assignment is trying to test you on, you can potentially get some useful information there that way. So if you do have issues with the assignment, you can figure out a way to rephrase the question so that it's generic. We will still answer it. Also, it's not a bad exercise because rephrasing the question in and of itself is something that might actually teach you more about what's going on. So, we'll open it up to questions now. Tawaka's asking about the assignment mark allocation. Yeah, sure, you can ask questions about that if you want. I wonder if that is the question that you're asking, or if you have a more specific question there. Let me just...
While Tawaka is asking their question, I have a question.
Yeah.
Functions in the assignment. Should I use them? Where should I use them? Do I have to have them? Summary?
Yeah, so functions are something that aren't really 100% necessary in the assignment. As in the assignment, you can get it to work without necessarily using functions. But if you want to get, absolute maximum marks in the assignment, you want to do well. Actually, you even want to get to the extension part of the assignment. You do need to do some functions. So you need to look at, we've had 2 lectures now, I think maybe 2 or even 3 lectures now using functions. And one of them in particular goes through what I would consider the kind of most elegant way to use functions if you can, where each function does one specific purpose, and the functions itself, sometimes they even call each other when they need to, and you'll notice that there's very little code in the main, and all of the code is pushed out into its individual parts. I think if I remember correctly, that was the shuffler. I had this card shuffle demo. So there is a specific question there from Tawaka. For the extension part, if our test cases don't manage to catch anyone else out, would we be deducted marks? Tom, should I throw this one to you? Tom's done a lot of work on the extension, so let's...
So the short answer is no, you cannot get deducted marks for your test cases. The way that it works is, even if you wrote the simplest test cases possible, if your assignment perfectly matched the behavior of the reference implementation, you would get 100%. So the perfect world is everybody does the perfect assignment and then none of the tests catch anyone out, and that's fine. What is more likely to happen though is that maybe you've missed a little detail of the reference implementation and you don't have a perfect working copy, in which case then you can make up the marks that you would have lost for that by having tests that catch other people out. And so it's not a subtractive thing, it's just an additive thing. So you can go over 100% effectively. It won't affect any of your other marks. There's no like carrying it over into assignment 2, but you can get the points for going above 100% by catching people out. But there's no detraction of marks. Does that answer the question?
Hopefully it does. I know this question. Hamish is asking here. Why should function signatures be at the top of the file and code at the bottom? Why not put the code at the top? You have a page down key or a scroll wheel. So I think let me log into VLab. Actually, while I'm doing this, Tammy, do you want to talk a little bit about
with the function, just jumping back to making functions in the assignment, I know when I first did my assignment 1, I never knew really how to do functions. Like there was just too many things to take care of to try and put things in functions while I'm coding. So the biggest tip I have, if this is like your first time like learning functions and stuff and you're not too confident about it, is to not worry about them first. Make stage 1 and stage 2 or like some kind of code working, then come back and try and put sections of code into functions. And if you're not sure what could be broken up into functions, like this is a very vague guideline to help you get started, but like all the different kind of tasks that we have in the assignment kind of helps you break up into functions. So for example, move laser could be a function, fire laser could be another function, and you can have functions inside that function if you identify things that can perform more specific functionalities there. And one thing that I want to highlight when putting things into functions that I've noticed quite a lot on the forum is a lot of students are trying to put the move laser functionality into a function. And something important to note there is when you're putting that into a function, it might make more sense when you're trying to do that. You might start passing in the laser Y variable because you need that somewhere inside the move laser function. And you encounter a situation where your laser Y variable is not going to update depending on how you've done it. So just wanted to remind everyone that when you're passing in a integer variable or some kind of variable like that, it's actually passing in a copy of that variable. So if you try and change that variable inside the function, it's actually changing the copy of it instead of the laser Y value you have in the main function. So you will need to think of how you want to deal with that when that comes up, if you're trying to put moving laser into a function. Yeah.
Tammy, can I ask you another question based on something you just said?
Yes.
Are you saying that I can have functions that then call other functions that then call other functions? And is that a good idea?
Yes, you can have that. In fact, I do encourage breaking up things if you need to break it up so that there's functions calling other function, calling other functions. That's totally okay. Especially because a lot of times that will make your code a lot cleaner where you only have like a 20 line, 30 line kind of chunk of code to read inside a function. And generally when people read things that are broken up into functions, they don't go, okay, well, here's a function call, so I'm going to go to that where that function is. Not like that. Well, how I read it is I see the function call, I look at the function name, and I assume what the function is going to do to my code, and I just continue to finish reading that function. Then I go on to read the next function. So it's a lot easier to follow because you're kind of abstracting away some of the logic to help you go through and understand what the overall function of the code is, I guess. Yeah.
I always love it when we get called out using keywords to mean something else. Okay, so I just want to go to Hamish's question in the chat about function signatures at the top of the file, code at the bottom, and the idea that maybe we could put all of the code for the functions at the top of the file. So I just want to show you an example here. This is the one that, so if you want to go and look at sort of elegant use of functions, then I found it. It's lecture 8. So I can't remember what else is in lecture 8, but this is the demo that we did here that has 4 functions, and then all of the functions are down here, and particularly it has this this main here, which just has 4 function, well, not even 4 function calls. I think it's got the 3 function calls and not much else in the main. It makes it really easy to read. But the question that Hamish had was like, given these things up here and then their code down here, why don't we just have the code up here? So one of the tricks that we have, okay, so the first thing is a very simple thing, is just readability. Is people are going to look for the main, and so they're going to see like basically the first set of curly brackets where this indented code is always going to be the main program, the thing that actually runs. So, and I know that, yeah, we could find this if we wanted to with just a search function or something like that, but sometimes, especially when you're working with multiple files, it's good to be able to see which one has the main in it. We'll actually often name our files to say which one has the main function in it. But there's another thing that happens here which is quite interesting. So the shuffle function here uses the swap nums function. So in order for shuffle to be able to know what swap nums is, swap nums has to be before shuffle somewhere in the code. So if I did something like this, I'm just cutting and pasting here these 2 things, and so I put shuffle before swap nums. So if I change the order of the functions, just the order that they're written in, which has no meaning at all for how they work, it's just the order they're written in, and I don't have these declarations of the functions beforehand, shuffle won't be able to run, because shuffle won't know anything about swap nums then. Hello, lecturer in charge, come to say hello and help teach us stuff.
Can I add one other thing?
Yeah.
Hamish mentions using recursion in the extension. Recursion is fine in the extension, absolutely. If you think it'll help, you should try it out. The relevant thing about recursion, though, is that you can also end up in a situation where you have one function that calls a second function that calls back to the first function. So even if you could figure out, in this case, how to order all the functions correctly, which is a pain, you might end up in a situation where there is literally no correct order because both functions rely on each other. That doesn't happen a lot, but it's just the sort of thing that, like, if you're thinking about recursion, that's a really good reason why you'd need them at the top.
But it definitely does happen. Like, we've all written programs where a function calls a function, and then another one calls another and another, and then they end up in this kind of cyclic sort of thing where there's no possible way to order them. If they were just, it had all of their code declared only once, there'd be no way to order them so that the program could work. Whereas if you say all of the functions, you just say how you could call them without saying what they do, then anywhere you can write the functions down here, it doesn't matter which other functions they use, they already know, they've already got the table of contents up here that tells them all the possible functions that they can call. And so if they know all the possible functions they could call, then you don't need to worry when you create them about any kind of ordering. They just go in any way they like.
As a quick comment on that, the problem of how you order those comments or order the functions is in and of itself an interesting computer science problem. Also, having the code at the top is really useful, because imagine that you had comments up there that said, here is what this function expects, here is what it does. You could probably send that bit of your code to somebody else, and they'd understand what your code did without having to read the implementation. And that's foreshadowing a thing that's going to come up later in the course where we actually do that.
Yeah. So hopefully, Hamish, that gives you a bit of information about why we separate the declarations from the actual definitions like this. It's actually an ordering thing where if we only had definitions and we didn't have the declarations, then there's like many kind of programs that we could write that wouldn't work. And also that would mean that every time we write functions that may use some of the other functions, then we have to start thinking really carefully about how we order them, as opposed to at the moment where, because we have this up here, when we write new functions, we can just put them anywhere in the list here. We could arrange them by categories, we can arrange them via when they're used chronologically and stuff like that here. We can actually organize this. Whereas if we didn't have the declarations, then we wouldn't actually be able to organize this. We'd be forced to order them in a really specific way.
The other thing is that I think is more of a style thing. The other thing that putting function prototypes at the top is because main is the entry point of your program. Generally, when people read through your program, they're going to start from the main. So if you, for example, have got like 15 functions or 10 functions, and you define them all at the like above your main, then you have a lot more scrolling to do. Because you scroll down to the bottom, read the main, and you come back up and look at the rest. Whereas if you've got like that function prototype kind of table of content, it's kind of a nice summary, like table of content, borrowing Mark's words, which is a really good way of describing it.
Yeah. Hamish is like, as a Python JavaScript dev, I still hate it, but it's okay. I think that's quite a funny response, because I think that those languages kind of partly have been built with a response to this in mind. So their compilers don't read the code once, in a sense. Like, they will go, well, Python doesn't even have a compiler in a sense. It compiles as it runs. So they're able to just kind of jump around and look for things, whereas C is very kind of one hit, in a sense. Like, it goes through the code only once and then wants to reliably create an entire program just from one run through the code. Yes.
On that, I just really quickly want to say, I don't want to go into it now because it's probably way off topic, but Hamish, if you'd like to know why it's the way it is and why Python and JavaScript are different, there are actually really good reasons that might make you think that it makes more sense. If you want to ask about them, ask on the forum and I can write up a better response than I could give here.
Yeah, we can give a longer rationale. And also, I think it's like, we probably don't want to go into discussions of different programming languages here in stuff that a lot of people are going to watch when we're only working with C in the course. Okay, so Tawaka was saying, can you create functions like that in other languages, declaring it at the start and then filling in the functionality later? Depends which languages we're talking about. The answer is yes, but like, the details are based on the languages themselves. So you can definitely do it in C++.
C++ is pretty much the only other major language I know
C++
of
is just an extension on C, so it's kind of like... I'm being a bit facetious when I say you can do it in C++. But otherwise, Java doesn't do declarations, does it? Java's able to read through to the other bits and pieces. Yeah, it's nearly like you're getting a history lesson in layout of functions. So C started it, and then later on people were like, could we do this in a way that's a little bit more human-friendly? And then things shift in different directions. And you end up with something like Python where you don't have to care that much. Like, you can treat your code like it's this bottom end here, and you can assume that your compiler's not reading top to bottom. It can just find what it needs anywhere in the code.
I'm going to throw in the word linker here, which is the reason that we need this, but I'm not going to go any further than that because otherwise it's its own... There's a whole course on why we need this, basically. If you want to take it, it's called Compilers, COMP1511, and they go into some detail about why things are the way they are. Yeah. But yes, C there aren't that many languages that do it the way C does it, but there are good reasons why C does it the way that it does.
Big can of worms there. Potentially a year or two worth of study to open that can of worms and understand what comes out. Okay, I can't pronounce the name. Minabie. I'm not sure if it's a nickname or something, or initials or something. Can you explain again why the arguments inside the functions change from when we declare it before the main and when we write it inside the main? Let's have a look at the code here and see if we can figure out exactly what the question is that you're asking there. But you're saying the arguments inside the functions for when we declare it before the main and when we write it inside the main. So let's have a look at, say, read input here. Read input here says I'm taking an integer array called deck. Actually, let's use a different one because these are named the same. How about print deck here? So it takes a deck, which is an array of integers, and it takes an integer called length. And then when we use it here, we put this deck in, which is a different variable, but we also put num cards in here. So I think the question is, how come the variable that's going to put into printdec here is not called length? Like, why is this variable changing from here to here? So the interesting thing about functions is, while in the declaration it might say these are the variables that I as a function have, those variables actually only exist inside the function. So these are the variables that are going to be created inside the function, and they're the variable names that the function is going to know these variables as, but it's not necessarily what the main knows these variables as. Let me I know, Tammy, that I saw you showing this in your tutorial, actually, that and so I'm going to copy your diagram if you don't mind.
Sure thing.
So this is funny because I think you're seeing the visuals like a few seconds behind because you're seeing the visuals on the stream, Tammy, but you're going to hear my voice a little ahead. So in my main, I have a deck, which is an array of things. I'm not going to get too detailed with this because it doesn't really need to be detailed. And I have a number of cards, which was a single integer, I think. And then when I call the printdec function, it actually creates its own little piece of memory that says, okay, this is where I'm going to run things. This is where I'm going to do my thing. So when I pass the variables into printdec says I've got two variables that I'm going to use. One of them is called dec. It's actually a pretty good example because the names are one of them's the same and one of them's different. So printdec says when it runs, I have my own dec and I have the length that I'm going to work with. So there. And so this will create these. The interesting thing about the array is the array is actually a pointer where this dec aims at this piece of memory, and this dec here also aims at the same piece of memory. But let's say 1, 2, 3, 4, 5, 6. This was the number 6. This one gets the number 6, but you can see from the two different pieces of memory that this variable here is not the same as this variable. They both happen to be containing the number 6, but they are not the same variable. Each of them has its own little piece in memory that exists. So printdec makes a copy of these variables. Even this dec is not the same. So like one of these is just trying to use different colors. One of these is here, and one of them is here. They both happen to be pointing at the same thing because array variables are memory addresses, which is the same as pointers. So they both have access to the same array, but they're still different variables. So printdec has its own set of variables, which has said, these are the things I'm going to create when I run, and I'm going to create them using some information you give me from the main. So I give you this information from the main, which is the number 6. Printdec creates a new variable called length and gives it the number 6 to begin with. I give you this variable, which is the array of cards, the deck of cards, and then printdec says, cool, I'm going to make a copy of that, which gives me access to the same array because these two decks happen to be pointers, but they're still two different variables. So in printdec, inside its own space where it runs, it has its own variables and it gives it its own names. And the interesting thing about having its own variables and its own names is they can take values given from the main, and so we can say which value we want to pass into the function, but when the function runs, it has its own name for things. So we come to printdec here and it says, okay, I created a new variable called length, and I got given some information with which to create that variable, which was the num cards variable that I got given from my main here this variable, but it's not the same variable. So in the context of its own running, it says, I don't know what numcards is. What I have is my own variable called length, which took the value out of the variable numcards. But the variables don't actually move around. The variables stay in memory in their own memory spaces, but I can give the concept of the number 6 I can pass across to the other one. So hopefully that tells you a little bit about what's going on and the difference. There's like a crossover point between what one function knows and what another function knows, and the only way to transfer information between these two functions is to pass something in as input. But even when something's passed in as input, it gets recreated at the other end as a new variable. So hopefully that helps. Yes, good. They're saying thank you, I got it now, which is good. Tom and Tammy, did you want to add anything to that? Happy if you do, or yeah.
I think another thing that students sometimes get confused is, Mark, can you go back to the code, please?
Code, yeah.
Yeah, thank you. So another thing that the students sometimes get confused is when I declare the function prototypes at the top before the main, why do I put like int dec and then like square bracket stuff, int length, that stuff? But when I call the function, I don't really need to put the int, the type in front. Sometimes students get confused about that, like what's the difference there? And this is a totally different question, but like I've just noticed that.
Still worth talking about, yeah.
Yeah. And how I like to think of it, I don't know if this will confuse everyone a little more, but is an analogy of the toaster, which I think other tutors might also use, where we think of functions a little bit like toasters. And because toasters perform a certain functionality, and that's toasting your bread or making toast. And so it takes in bread and it gives you back toast. And on your user manual, it might say that somewhere. I don't know if it actually says that, but assume it says that. It's going to describe the functionality in some way. It's going to say, okay, well, this particular electrical appliance is going to take in some bread and it's going to give you back toast, right? So that's kind of like the function prototype you have at the top before your main function, because that specifies, okay, what's the function's name? And then inside the curve brackets that we have, like where it says int dec, int length, that's telling us that that's what type of stuff that function takes. Just like in the user manual of a toaster, it tells us this electrical appliance is going to take some kind of a bread. Like it can take some slices of bread to toast, essentially. And then when you have the function call inside your main, for example, like on line 23, you've got like print dec or like read input or shuffle. That's when you're actually using the function. Just like when you actually take your toaster, plug it into your power supply and use that toaster. So this is where you take your actual bread, actual slices of your bread on your table. It might be white bread, it might be, I don't know what other breads there are, but like essentially you take that bread and put it in. So it's literally what you have at hand. So in this particular case, it's passing the dec, which you've declared on line 20, which is the actual array you have at hand. So it's different from saying int dec on line 15, for example, or on line 14 where we have int dec, because that's only saying we're going to take an array of integers of some kind. Like you can give me any array of integers in that sense. But when you're calling that function inside the main, you're actually giving an actual deck of cards. Yeah.
Yeah, that's cool. Yeah. I remember seeing that somewhere in, I think it was your tute actually, where like talking about functions as appliances, and I was like, that's a really interesting one. Like I think that can really help. Okay.
Question. Do you want to move on to that?
Oh, sorry, Tom?
Oh, I was just going to say, do you want to move on to the question about commenting declarations of functions?
Yeah. Do you want to answer that one?
I'm happy to.
Yeah, go for it.
The answer is, for assignment 1, we strongly recommend that at the top of each function, you have a comment that says, like, this is what this function does. Just like what Tammy was saying with the user manual, you want to have something that explains it. Like at an absolute minimum, if you wanted to minimize the comments in your code, having a comment at the top of each function would be necessary. For this assignment, we recommend having it above the actual code, I would say, but it doesn't matter too much whether you put it above the prototype or above the actual code. In the second assignment, it will be a little bit different because of the way that that's set up. But for assignment 1, comment above your functions.
Yeah.
Yep.
Okay.
Up to that, what if you have a lot of function signatures? Tammy, what should you do if you have a lot of function signatures? Anything in particular? Or is it okay?
I've seen some people's code which really nicely sections them out. Like if we're talking about a bunch of function prototypes, is that the question?
Yeah.
Someone has 11 function prototypes.
Yeah, so if there's like a lot of function prototypes, what some students do is they try and section it out in different ways. So some students might just divide it into different stages specific to the assignment. If you're talking about the assignment, so like they will have like the comment about this is the stage 1 related functions that I have. So these are the function prototype for it. And then they have a new line and they comment stage 2 functions here. So it's really nicely laid out, being like stage 1, stage 2, stage 3, stage 4. Another way people do it is by like functionality essentially. So everything related to like laser or move laser, they will have a section for it at the function prototype. That's if they've used like actually that many functions for like, you know, move laser or whatnot. But yeah, just sectioning it out would help the reader, but it's not a biggie if you don't end up sectioning it out either. It's just that's what I've seen some students do, and it looks quite nice.
Yeah, I guess like you're talking about having 11 of them. That's not that many. You can just put them in one chunk, and it'd be like, okay, here's 11 lines that you might look over if you really want to go into the details. But otherwise, just sort of you can scan that list and go, okay, these are the functions that exist. So some people organize them, but I don't think you necessarily have to or anything. And I know it's funny because 11 seems like a lot right now, but you just wait.
If you had 100, I would probably want to organize them. But yeah.
If you couldn't see them all on one screen, then I would definitely want some kind of organization. Yeah. This is an interesting question. Can you explain what's different between global static and local variables? I wonder if we can look at some code. Actually, that's not code. This is one of my images. So, I mean, let's just disregard the static for a moment there, because that's something that has the static keyword, which we are going to look at a very, very small amount in this course, has different meanings depending on what you use it with. But there's a concept which is a global variable, which I can show you a kind of an example of, I guess, here. Is basically at different levels of your program, there's different curly brackets. And every time something's contained in a curly brackets, it only exists within them. So if I have these curly brackets here, only these two variables can only be accessed within these curly brackets. The only reason there's information from them going into any of these functions is because they're explicitly passed into these functions so they can be used. But there's this thing that people used to do. People don't generally do it nowadays because, honestly, it's just fraught with danger. But if I did something like this, and I declare a variable outside of my main, because this variable is not contained within any curly brackets, it's accessible in all of them. So basically, anytime you open a curly brackets, everything that existed beforehand can be looked at inside of. Like, for example, here, int I equals 0, then I open a new curly brackets. That doesn't stop me from using I. I can still use I inside because I is at a larger kind of scope that exists. Tom or Tammy, do either one of you want to talk about global variables? And just like what you suggest with them, or maybe even, because this is leading definitely towards what something I would have said is like, what's going to go wrong if I have these? Does one of you want to talk about
things?
Yeah.
So what you just described, global variables are unsafe for a bunch of reasons, but the main reason is because what could happen is that you call a function once, the global variable changes, When you call the function again, the global variable is still changed. And what that means is it's really hard to reason about, like, if I call my function 5 times, it's going to do a different thing each of those 5 times, and you can't tell why. There are also things that once you start having your bigger programs that like run on multiple different processors, you get really big bugs. And that comes up a lot in 1521 and operating systems, where you'll have like crashes, like the blue screen of death is often caused by global variables. So the advice that I would give is basically, if you feel like you need to use a global variable, have a chat to a tutor or post on the forum, because there is almost certainly another way to do the same thing. And that other way will almost certainly make your code nicer and easier to debug and easier to work with.
Yeah, I think one of the biggest risks is this is now accessible anywhere in this program, which means we don't know what's happening to it. We have no control over it. Whereas if we have this variable here, we know that the only way this variable can be changed is if there's a function that accepts a reference to this variable, so a function that takes a pointer to that variable, or we explicitly do an equals to this variable, so we do something that changes it, or not just an equals, like a plus plus or a minus minus, things like that. We can see the commands that change it. If it's out here, we have no idea whether things change it or not. So things that don't have the variable's explicit name in the line that uses it could still change it. So I could write another function that doesn't appear to have any effect on this, but it can affect it. So like this variable becomes inherently kind of unsafe, like because we don't know what's happening. That's like one of the biggest issues. Whereas if the variable's in here, I know that the only way any of these functions can access that variable is because I have specifically given that variable to the function. So if I have a theoretical function called change num cards, and it takes the address of num cards, then I know that this can change that variable. But I can look at all of these other functions and instantly know that none of them can in any way possibly change this variable. So I know exactly where this variable can change or not. So if I find out later on that this variable ends up with an invalid value, then I know that there's only one place I need to look, something that actually had access to that variable. As opposed to this, I don't know if it's equals 0, like I'm just initializing it as 0. This variable, I have no idea who has access to it. Or worse, I know that every single function in my program has access to this variable, which means if it ends up an invalid value, I have to go digging through everything to find out what changed it and what made it wrong. Whereas in this situation where the variable is kind of protected inside its own set of curly brackets, I can look through and I can say this is the only one that can make any changes. So this is where I go to start my debugging. All right. So you can see immediately that like this is just like a can of worms. Like there's so many places that could change this, and I don't know which of them will or why, as opposed to here where I go, okay, this is where I start my debugging. So hopefully that helps a little bit. I mean, yeah, we could see that this potentially gives us more power over the variable because every function can affect the variable, but it's like not protecting ourselves against that that same eventuality of every function being able to access it. So anyway,
can I say 2 things
about
go
this?
For
it. Let me come to your face.
The first thing is very quick. Just about static variables. We didn't mention them too much. They don't do what you think they do. Like when I came into 1511, I thought I knew what they did. I didn't know what they did. The reason I mention this is just like, don't just think that it means a constant. It's not that. So be careful. And just don't use the word static with variables, I think is the best rule there. The other thing I wanted to say is that not using global variables, even though we've now shown them to you, you still shouldn't use them. But that comes under this broader idea of what we call safe programming or defensive programming, which is this idea of like, we don't just want to write code that works. If possible, we want to write code that's easy for us to tell when it goes wrong and easy for us to debug and like it shows us errors when something is wrong. And that's especially if you're sort of getting to the point where you've done a little bit more of the assignment and you're trying to like make it really good. One of the things that can be really useful to do is to start thinking about things like, have I written my code in such a way that if there was a bug on line 300, I would get told about that bug earlier. There's some if statement maybe that says, oh, this shouldn't be a valid value for this thing. Something's wrong. Have I written my code in such a way that I can follow through and I can say, well, this variable got changed here and here, and I understand it couldn't have been that one, so you sort of know where to go start looking. That's a skill that like you can't just teach, I think, because it takes a lot of like you run into a bug and then you realize how to not do that bug again. But it's one of those things that I think comes up more and more throughout uni and even throughout the workforce as well, of like trying to write code that is easily debugged, that is safe, that is sensible.
I think the more code you write, the more you realize that it's not that important. The code, like the writing of the code, is not the thing that takes the most time. It's the finding out why it didn't work and rewriting it for new purposes is the thing that takes up most of your time. And so the more you can make stuff that's really easy to modify, really easy to track, the more valuable that code is.
Like as an example, the number to words exercise, or the word addition one, where you have to write out like 30 if statements, like that's a good example of somewhere where you've got so many different things in there that could go wrong. You have so many lines of code. Having a shorter program, maybe, if you can figure out how to do that, is actually really valuable. And you want to try and program it so that you've done that correctly and you've, just so that it's easier to maintain and understand and fix.
I do really enjoy that exercise, word addition. It's a challenge, so not everyone has to do it. But those people who do it, I kind of like it's a perverse fascination, but I enjoy the amount of hate that particular exercise gets, because I think once you're a few weeks after that exercise and we've given you all these different tools to deal with the situation, we still haven't given everyone all of the tools I think necessary to deal with the situation. There's one more that's coming next week that I think helps a lot with that one. But actually, no, you could do it with a 2D or a 3D array. I think an array of string. Oh no, you can't. No, you got to use structs. I shouldn't say keywords that I haven't taught you yet. But it's really really easy if you have this other one, like to do it. I think because you can set up this data structure that just maps the numbers to the words. But anyway, someone's saying dictionaries. Yeah, dictionaries actually would be really handy. Actually, no, you can do it with just an array of strings.
You just do it with an array of strings.
Yeah, just do it with an array of strings. Anyway,
which would be technically a 2D array.
Yeah,
anyway.
but what I love about the exercise is it puts you in a situation where you need the proper programming tools to make this thing work, and you don't have them yet. And so everyone gets angry with it, justifiably. But then later on you go, I don't have to be angry at those things anymore because now I found the tools to use them. And it's actually quite rare for us to be able to put you in those situations. So oftentimes you don't know why what we're teaching you makes sense. And so that's why I love word addition, because it actually shows you how bad programming could be if we didn't have all the toys. And then when you get all the toys, you're like, oh, that thing's really easy now. I could knock that thing over with like a few lines, And that's definitely not the only time you're going to get into that situation where what you have on hand is not capable of dealing with the task. And that's not just, and I'm not even talking about programming here, I'm talking about your approach to problem solving and stuff like this. Later on, you're going to be like, I remember not having enough experience to be able to deal with these kinds of situations, but now that I know it, it makes so much difference. And that's the miracle of learning. The joy of figuring things out over time. But unfortunately, it's hard for us to just put all the situations in front of you that give you context for everything that we're teaching. But word addition is a great one, because everyone hates it the first time they do it.
The lecturer so during week 6, there are other lectures which I think we've put up, which are from Carol Morgan, who's a professor in the school.
The video is up, actually, so people can watch that. Hang on.
The reason I bring it up is because his course, or one of his courses, COMP1511, which is a course that I took 2 years ago, I think, he mentioned this idea that he had for writing another course called Programming via Pain, or something like that. And his entire idea of this course would be to give you languages or give you things where you didn't have the tool that you needed to solve the problem, and you had to solve it anyway. And his thought was, well, if we make people solve these problems in the hard way, then you're really appreciative and you understand why it's so useful. So I feel like word addition is a lot like that, where it's like you don't have everything you need, but you have to do it anyway, and then you become really like, oh, I now understand why this is so useful and interesting.
Okay, let's have a look back at the questions and see if people had other questions. We were talking about using IntelliSense and stuff like that, so I guess people are using VS Code a little bit. Hamish has a couple of questions. One of them is, why does declaring an array and initializing it using another array not work? So how come we can't just take the contents of an array and use them to create another array? It's an interesting one. Do either of you want to take that one?
I can try if Tammy doesn't have a good...
This is great. Okay, so what you get now is like this hilarious view of what it's like to be a lecturer. Because if you're a lecturer, you've got tutors, and these tutors work for me. So when I can't figure out the answer to the question quickly, I throw to them instead, and I throw them in the deep end. Oh, wait. Sorry. You said rather than initializing using the contents of the other array, the question clarification is, can I make one array as a memory address aim at the memory of another array? You kind
Can
of...
I...
Wait, actually, no, Tom, you look like you wanted to say something.
Do you mind if I take... Yeah, because I when I read this question, this is an interesting one.
Yeah.
So when you say int array2 and then the square brackets to define something as an array, what you're doing there is you're actually creating a bunch of memory for that to for you to store things in. So when we say, int array square brackets 10, that's assigning 10 integers, which are all next to each other in memory, which you can sort of set things in. When you then say array2, and you also make it with the square brackets and it creates 10 integers, that's initializing a separate piece of memory from array1. Now, the reason why that's important is because if you were to say array1 equals array2, array2 or in fact, do it the other way around, array2 equals array1, let's say, array1 in that context, it's a pointer. It's not talking about the entire block of memory. And because you're trying to assign an entire block of memory, that is array2, which is the square brackets 10 thing, to be equal to a pointer, that doesn't work. And C doesn't understand what's going on. Because C doesn't have this concept of like assigning one array to be equal to another array, all it can do is arrays are pointers, and therefore I can assign pointers to pointers. You can't say that array2 square brackets 10 equals array1. If you wanted to end up with two pointers to the same piece of memory, the way you would do that is instead of asking for square brackets 10, that is asking for 10 pieces of memory in for 10 integers, you would say int star array2, and then what you're asking for is not 10 pieces of memory, you're just asking for a pointer, and then saying int star array2 equals array is saying make this pointer equal to this pointer, which is totally fine. So that's the difference there. It's the difference between the square brackets, which creates 10 pieces of memory, and int star, which just creates a pointer, which you can then assign to be equal to other pointers. Hopefully that's a reasonable explanation.
I was live illustrating it while you were talking about it, and hopefully that helps. This works really well. I've seen this done before, where there's like one person teaching a concept and another person just drawing a picture. And I was like, I saw an illustrator do this at something, and I wanted them to like just be in my lectures, just illustrating my lecture while I was talking about it. And I'm not sure I can afford that, because I think that's like another complete like full-time salary alongside my lectures, but it would be so cool if it was.
Okay.
So hopefully, Hamish, that is making sense, that like the declaration of the second array claims all this big chunk of memory. So even though the array's name stores the memory address, it doesn't necessarily mean it can access that other piece of memory, whereas if you do it as a pointer, you can go, yeah, this pointer will have the same memory address that is stored in the array, and so this actually in this box, this memory address would be here, and it gives it access to the same thing. Hamish had a second question, which I think was a second clarification of the same thing. Don't expect a copy of the array, but since the array is a pointer. Yeah, alright, that was your clarification, which I should have read.
I think they were part of the same question.
Yeah, there were
There's
one
a-
out
there's
of two
one
and
out
two
of
out
two
of
and
the
then
same
two out of two.
question.
Yeah.
I read it incorrectly as two separate questions that were being asked.
Hello again, Tammy.
Oh, Hussein was asking a follow-up question on the functions earlier. How many functions would you recommend we start to organize them? It's hard to put an actual number on this, but I would... You know, there are actually magic numbers that exist, and they only exist because we're human. So human short-term memory can juggle usually... and this really depends on who you are and like what kind of memory. Some people have that idea of photographic memory and stuff like that. 5 to 9 objects, and you'll see good websites always have this kind of thing where there's only a maximum of 5 to 9 options available to you at any time, and this is what's known as human cognitive load. And most programming style is based on the idea of human cognitive load, like how many things can someone read at a time and still actually keep them in their brain at the same time. So 5 to 9 is the thing where we don't need special techniques to be able to understand things. So you go 5 to 9 things, and if you go over the 5 to 9 things, and it's a rough thing because this brain is like a mushy piece of flesh, not digital, right? So it doesn't adhere to exact values on things. So roughly 5 to 9. Then if you get beyond that, then if you have 5 to 9 categories of things, then you're fine. And anything less than that number is also fine, you know? So I would roughly say around there. If you want a hard number on it, you could be like, once you hit 10, maybe you should organize them, you know? But, I mean, sometimes you don't need to. It's a very, it's a mushy brain thing.
I think it might also just be worth noting that sometimes there are really natural groups of functions. So for instance, if you've got a function to do some scanning and a function to do some printing, they'll often really nicely fit together.
Yeah.
And so you can kind of have them as a separate group. And if you see natural patterns like that, that's a really good time to jump in and just separate them so that they're really clear that those two things go together.
And then immediately those two become one in the 5 to 9, then you'll be able to think about more of them.
That's such an interesting thing. I just started counting everything I had in all my YouTube chats and stuff. It's literally a range of 5 to 9, all of them.
Yep.
Yeah.
So it really depends though, because you will see some websites. This is so funny. We're now teaching a different subject. So if anyone's interested in this kind of stuff, COMP1511, which apparently, because I used to tutor that subject years and years ago, apparently some of the stuff I wrote is still in that subject, because I wrote a bunch of the tutorial content. But if this isn't great. Oh yeah, there's 9 here, and then add shortcut. So Google's this is the... Oh wow, you can see my Games Workshop links. This is the limit of what Google's going to show you at any particular time. But I think let's see if we're following our own rules. So UNSW in each section. Oh my god, Dr. Fauci is talking? Sorry, getting distracted. See how there's only 4 options here? And there's so many things to do, but each one of these columns has a maximum of 1, 2, 3, 4, 5, 6, 7. So you go one of these options, and then you have 5 options to choose. And from those 5 options, you've got 7 options here, right? So instead of having all of these things available on the front page, the UNSW website is saying, okay, go to this one thing, and then go down to this other thing. And every time you have to make a decision, there's only 5 to 9 things at a time. So even like those drop downs and like, so if we just go to any of these, what's our research impact? There's only 5 things here, even though I'm pretty sure UNSW has more than 5 research topics happening at any particular time. So you get that kind of thing. Anyway,
can I steal your thunder for a second? I realize this is very, very slightly off topic, but it's also
we're so far off topic right now. Yeah.
But then again, I have a feeling that
everything's on topic because this is an introduction to computer science. So anyway.
I'm imagining you're going to mention this on Friday. The stuff that we're talking about is entirely 100% computing. But I don't think if you asked anybody sitting in 1511 right now, what is computing, they'd come up with the answer, designing your interface in such a way that people can understand it easily. I think that like 1511, obviously we focus on programming in C because that's what the course says that we're doing. But please don't feel like the only thing in programming is programming and you have to be good at C to be good at this. There's things like security, there's things like HCI or human computer interaction, which is COMP1511. And like, even if you graduate, you might not write any code for the rest of your life, but you'll still be a computer scientist. You'll just be doing interesting different things or project management or that sort of thing. I think this is something you said to me, Mark, actually. Like it's only like not everybody who graduates here is ever going to write code again. And that's okay. You're still a computer scientist. And thinking about these things is really important and interesting. I wanted to throw that in there.
I think I'm trying to think. This is the funniest thing. The funniest thing is I'm just going through all of my friends who graduated from computer science degrees and have full-time work and stuff like that, and I'm trying to find anyone who still codes. And I've just gone through like about 8 people in my head, and I haven't found anyone who codes yet. So I think, like maybe earlier on, people will do a bit of coding. So like I was coding a little bit in my not even my first job. First job wasn't a coding job. Second job was a coding job. So I worked for 2 years as a computer scientist without doing any coding initially. And then I've got friends who do stuff like consulting work where they help a company structure their company so that they can create code properly. And there's no point being a coder for that. What you're doing is you're helping people organize who's coding when and how and things like that. I've got another friend who's a user experience architect. So that's like the upper high end of that idea of like, just the 5 to 9 objects at a time kind of thing. And I've got other friends who are like sort of systems architects. So they basically put their massive expertise onto a whiteboard, and then a team of like 50 people goes through and picks pieces off that whiteboard and actually codes it and stuff like that. So like, yeah, it's really interesting. Like, this is really funny. You've got me racking my brain now. Like, totally racking my brain to try to find a coder out of my old friends who all have computer science degrees. And even I don't count, right? I don't, like, my primary, source of my profession is speaking, not coding, Like, if I want to, I could actually talk to these two and say, you write all the code for me. Like, I could, if I wanted to go, like, really, really full on, I could be like, I'm not even going to write my lecture demos. Like, it actually could work. That would work really well. I have one of them coding while I explain it. So if one of you was sharing your screen and writing the code, and then I'm free to just talk about it, that might actually be even a more efficient way to run 1511 than I'm doing it, Because then I'm there talking to chat, talking to humans, presenting to humans, which is what I do as a computer scientist. Is like, the interesting thing is I've crossed over this threshold from writing code myself. It's now not that valuable for me to write code myself. But if I can inspire a few hundred people at a time to write code for the future, that's going to have more impact on the world than me writing any code myself. Because I'm just, like, honestly, just not that good a coder compared to what some of you are going to be. So, like, it's actually interesting that, like, I can give more to computer science and the global community of programmers by convincing people to become programmers than I can actually doing any coding myself. So it's weird, right? Yeah. Anyway, we launched into a pretty.
There's a nice big derailing, but if people are interested, I assume this is going to come up in your professionalism talk on Friday.
Yeah, this is exactly the kind of thing that I'm talking about on Friday. Like there is a section on just like, how important is it to be able to program in computer science? And it's like, for some of you, like, I'm not gonna lie, for some of you it's 100% important. Oh, I did think of someone. Who, because, like, you know, for me it's like 20 years out, you know. But
After how many people you thought about?
Oh, I think there's about 15, 20 people I went through in my head. Yeah. But I know one person who is still on the tech track in Atlassian. So he hit a point where... Because I've got, like, two friends who are the same age and stuff. One of them has 100 people under him at Atlassian. So, like, he's not touching code. If he touches code, then something falls over. You know, if you have to pay attention to 100 people, then something falls over if you're getting your hands dirty. But I've got another friend who's only got, like, 3 or 4 people under him, and he's, like, a technical lead. And so his entire job is, like, make code very, very good, and get these people doing very, very good code. So I found one eventually. Yeah.
But I mean, you think about it, like, the number of people that they need experience is much less than the number of people they need who can just write code and do stuff, which isn't to say that that's not a great job, because it's an awesome job, you know, writing code, and you'll probably, you know, make a lot of money from doing it. But, you know, when you turn 30 or 40, if it's not really your goal to become one of those, like, tech lead sort of people, there are lots of, like, offshoots into... There's a question from Hussein, which you sort of answered, you know, like, where else do you end up? There are places like management, there are places like other roles like design or UX or teaching, or even just, like, entire career changes when you get to 35 or 40 and you're like, I've loved doing this, but there's something else.
I wouldn't push it that late. I think the first career change I've seen in most of us hits us in the mid-20s. So, like, you'll get your first job, and that'll be your career. And in general, a career lasts for, like, 5 to 10 years, in a sense. So you can be, like, straight out of university hotshot coder, because that's the funny thing, is, like, being a professional is, like, most of the hotshot coders are straight out of university. And then after a while, they're like, oh, God, I just can't keep up these hours of coding. And then they go, okay, I'm going to do something else. I'm going to broaden my horizons.
The Mountain Dew stops working.
Sorry?
The Mountain Dew stops working.
The Mountain Dew, yeah, the Monster Energy drink.
Yeah.
Anyway, let's go back to programming questions, because there are actually programming questions there.
I think we've...
Hamish asked a question. I think that's where we're up to there. If you wanted a magic array, like magic numbers, would you want to hash define it? Can that be done? Or should we use a constant global, i.e. a const int array, something or other? This is interesting. Where did we do this? I know we did this in something, because, like, this was actually, like, years ago with the old subject admin, Andrew, who is working with me. We both solved part of the first assignment by having, like, 40 hash defines. And it was like, we were being so dodgy about it, but we were doing hash define 1, 1. So the word 1, and then the number 1. Hash define the word 2, 2. That's actually how you can solve word addition. No, not quite. I don't think you can do it with hash defines. I was just going to hash define the word into the number and stuff and have it automatically transfer from one to the other, but it doesn't work like that. But yeah, and we did that kind of thing for... What was it for? Was it for cards in a deck, or...
Either that or for Pokedex, because I know that they used...
Yeah, we had a Pokemon-themed assignment, and so we would have all these hash defines between... like Pokemon element types and numbers and stuff, so that then you could then store them in an integer array and sort them and things like that. We weren't doing sorting, but, you know, like, you could keep them in an order. And then you were storing in integers instead of strings and things like that. So yeah, it's totally possible. You can have a big bank of hash defines that do things. If you're ever going to do that, put some comments in, though, to explain why they're being used. Otherwise, things get really messy.
Can I jump in on that quickly? Yeah. I have a feeling that part of Hamish's questions was whether you could create an array inside of a single hash define, to which the answer is you probably shouldn't, because I think it will give you warnings. I can't be sure. We can try it if you want to, Mark.
It is technically possible just because, and this is like the stupid thing about hash defines. The super dangerous thing about hash defines is all that a hash define does is it basically does a global text replacement in your code. So it'll go through and say, everywhere I find this piece of text, I'm going to replace it with this other piece of text. So I've had students figure out how to type in Unicode letters, not just ASCII code letters, but Unicode letters into their code editor. I think this only works in Visual Studio and stuff. And so they had like the symbol for a smiley face take over the word while, and then a symbol for like this. There was like a butter knife or something took over the open bracket, and then something else, and then they just wrote what looked like complete gibberish, but it was fully functional code. Where's
this
Liz's yeet example?
Triple C that you're talking about. The which?
The yeet example from Liz has
Oh.
defined all these different spellings
Yeah.
of yeet to be different programming concepts, and so you had an entire program which was just yeet 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 yeet, and it worked because of the hash defines.
This is what happens in a competition called the IOCCC, the International Obfuscated C Code Contest.
Yeah.
And basically, imagine that we like everything that's in the style guide that we said to do, they said not to do, and everything we tell you not to do, they do. They try and make the most like unreadable programs that do something. And so there are like C programs that look like a picture of a dragon, but they'll actually play a game, or that like they spell out the text of the program in like ASCII letters, and then it actually prints out that text. There's all these crazy things that you can do with it. So it's worth noting. IOCCC. IOCCC.
I was gonna say,
Yes.
otherwise I'm gonna get the Olympics committee.
No. You should pull up some of the examples because they're amazing. All terrible to be doing this, but they're amazing.
This looks like C.
That is a C program.
Yep.
I think.
Main puts hello world. I think it is C, because it's not using any of the C++ bits. Oh, string.h. Oh no, string.h is us.
Yeah, IOCCC has to be in C, I think.
Yeah, so
you might.
You can see there's some hash defines here that are, what the hell's going on with those hash defines and stuff. Yeah, this is legal C program, and it's just funny because of
Just barely.
the shape.
Can I share my screen for 1 second, Mark?
Yeah. Oh, sorry.
I'll try and do this. My entire screen. We'll try not to get this to crash if we can. 1 second. So we're going to share that and allow. Okay, hopefully now my screen should be sharing.
Yep, it is now.
I'm not in VLab, I'm sorry. So what I did was I wrote myself a program called main.c. This is what my program looks like. So includes.io, hash define an array. So this is just to see whether we can have an array inside of a hash define, and then it tries to print out stuff from my hash defined array, and then we try and compile it, and so I think the answer to specifically answer that question about whether you can have arrays and hash defines, the answer is no. What we would do is probably have the const int outside of the any functions, but there shouldn't arise many needs for that. Like we don't do that in in our sample solution. So if you feel like you need that, it might be a good time to chat to your tutor and just say, hey, how would you do this? And if you really do need it, then the tutor will tell you and they can guide you in the right direction.
Okay, looking to questions. People are asking about what people do if they don't end up coding. I think we talked about that a bit. There's actually roles for people, like, and this isn't just a career change. It's not like the first job is coding for everyone, because it's actually not for a significant number of people. So there's a few roles on every team that are non-coding. I think the most common non-coding role, which is like not quite as common as programmers but reasonably close, is the product manager. So a lot of a lot of companies realized, and this is exactly like, you know what we've been teaching about problem solving and stuff, where people solve the wrong problem. If your entire team is programmers as a stereotype, so it's not always the case, but as a stereotype, we tend to just go off on tangents. We tend to be like, ooh, that's an interesting toy. I'm going to play with that toy. And like anyone who's programming, like a lot of people who get into 1511 just go, what's the next step in this particular thing? And most of the challenge exercises are based on that question. But the product manager is the person there who actually acts on behalf of the potential users of the software and says, this is the actual product. Like, not the code, not what we're doing, but the product must serve a purpose. It must serve some people in some way. So someone has to keep track of that and keep everyone on track. And even just the simplest thing a product manager does is to just ask people, how does that solve the goals that the product is supposed to solve? And then people just go, oh, it doesn't. But it was exciting
but we
to
need
build.
dark mode. We need dark mode, Mark.
Yeah,
what are we
everyone needs dark mode. Having said that, that is actually serving some needs of the users. So I think that's one of the things that, like, there are actually going to be plenty of people graduating from comp sci degrees who will immediately, upon leaving university, step away from the keyboard, in a sense. Like, they will immediately not be programming. But what they're doing is making sure that that an actual decision is made correctly on what we want to build and why we're building it. I think there's a course on that. Isn't there a course on product? I think it's one of the three. Matt Sladescu, is it his course?
3900 is the project course.
Yeah.
Which is Matt's course, but I wouldn't
think
say
that
it's
has
really
a very strong product management focus.
It does some work on product management, as I understand it. If you want to learn more about product management, just going to chuck in a quick promo for CSESOC, who there's articles on their website written by product managers who converted from a CSE degree into a product management degree, and they often have interviews with.
Hang on a second, I think the stream's died.
It was just lagging for a second. It
died
seems
and
to be
it's
back
back
now. Yeah.
I don't know. I just got a pop-up saying that OBS was disconnected, but then now the stream seems to be going at full stream. So maybe people won't notice.
Hopefully. Well,
at the other end,
I saw
you won't notice.
I saw a spinny wheel for a few seconds, but it should be fine.
Yeah. Okay. So, Hamish says we've nerd sniped him. Yeah. Like, I think when it's not structured and I don't have the slides going, we are going to talk about this today, and I have 2 hours to get this concept out, conversations can get a little bit more interesting.
One other, if we're looking for other interesting conversations, the other thing that comes to mind of things to say is, like, even if you graduate from a CS degree, what you don't realize is that we're not actually teaching you, and we're teaching you C, but we're really not teaching you C. We're teaching you a way of thinking. And when you graduate from CS or even this course, right, your thinking about the way that you solve problems will be slightly different to the sort of thinking that you'd get if you went down to the law school and you took a law course, or that you would think if you were doing a business degree or an arts degree. And so even if you never touch code again, the thought processes behind, it's kind of engineering, it's kind of a bit weird because of computer science, but it is pretty much the same thought process of, like, how do I solve this problem? What are the steps? What are the blockers? How can I integrate technology into this solution? All those sorts of questions are the sorts of things that you're learning answers to that are valuable to employers, even if you're not writing code right now.
Just adding on to that, it gets even more. It kind of seeps through your entire life, if that makes sense. Like, for me, it's not even about technology. Like this is personal experience where, like, in high school, I was more of an emotional person. When I came up with situations, I would freak out a lot more easily. And then after coming through, now I'm in my 5th year. You can clearly, I can clearly see the change in me where I react differently to real life situations. Like, it's nothing related to tech. It's nothing related to comp and stuff. And you're just like, wait, I'm thinking and approaching this in a much more logical way, and I try and separate it out away from my emotions a lot more with a lot of problems and things that come up in your life. So I think that's one of the most useful thing I've gotten out of the degree, actually.
It's just the ability to to see an unsolvable problem and know that it's actually made up of smaller parts that are probably solvable. That's a really interesting kind of thing, and I think that's it's a mindset you only get if you've seen a lot of apparently unsolvable problems that then you eventually can solve. The interesting thing is the deeper you get into computer science, the less of those are actually solvable. But I don't want to get people
There are some really hard
pessimistic
ones,
about
yeah.
You hit things that like people have been banging their heads against for 50 years and haven't been able to break, and you're like, oh, these exist again.
One of the things I'd say, this is a very specific piece of advice, I guess, but if you ever get the chance, go and talk to like a lawyer or to somebody who's gone to a very different school of training onto how they think. And I think I was very surprised, like talking to like some people in my family are lawyers, right? And I talked to them, and they're like, they have an entirely different conception of how the world works. And the whole idea of like moving fast is not a thing that occurs to them because their job is to get it right. Whereas we can iterate on stuff. Or you go and talk to an engineer maybe who's working on safety critical systems. They are going to think about things in an entirely different way because they can't solve a problem by just being like, YOLO, I guess we'll compile it and see if it works. They have to be like, if this doesn't compile, people die. And you pick up like this very different way of thinking, which is an interesting thought experiment to have. I realize that that's not at all on topic, but if there are any questions, by the way, it might be good to post them in the chat now. If there's anything else that people
there's
are
one, but
asking.
it's kind of not quite a question. But I was actually answering a text. But since we're, I'll just talk about it. So, Tawaka said game dev sometimes feels like an unsolvable wall, and I think the issue with game dev, and it's the same thing as like we're talking about 5 to 9 things and stuff, is that the only way to judge whether a game works or not is you put it into these squishy things and then you see what kind of effect it has. And so much of the effect that games have overall is not really based on what they are. It's based on what is the social kind of, what is the world like when they appear, and how do they reflect the context of the world, and what do they do socially, what do they do in a marketing context. Like, I think a wonderful example of this is Among Us, right? So Among Us is not quite as huge as it was like maybe 6 months ago, but it was like the biggest thing in the world 6 months ago. And the weirdest thing about the game was it was like 4 years old. Was it 4? It was really old when it got big. So it had its release, it had whatever hype was built up around it, and then it had died, and then someone picked it up on a Twitch stream, and then it just got big. So its success is based entirely on things that weren't part of the game, and the code in the back end could be just trash, but like it didn't matter because it ran well enough to be picked up in an interesting way, and then it hit a point where everyone was stuck at home, and it was a good way of interacting with people without being able to be there in person. And so it just struck a nerve at the right time in the right place, and it became huge. So I think like it's really, really hard to judge games in this kind of solving problems thing. Our whole engineering perspective is not what makes sense for game dev, right? Because this engineering perspective is like, what are the problems that humans have? How do we break that problem down into solvable parts and then create software? Well, for us, other people create like physical things, but still engineering, same process. Find something that makes this problem go away for people, or gives people a new way of doing things, which is better. Whereas games is like, how do you put people in a position so that they can experience something in a particular way? And that's why there's this kind of the difference between art and engineering, in a sense. Engineering's really kind of problem focused. Art is like experience focused, and games crosses that line where there's obviously engineers in games, but the make or break for games is more about the art side of it. It's like, can you express something in the game to take people on some kind of journey, whether it's an emotional journey or a mental journey, or even just like, can you create something so that it becomes a ritual and a pastime, so that people will go in every day and do simple things with it? And that's also even an emotional journey. Like, I feel like Animal Crossing like hit at exactly the right time. Like, it released just after the whole world went into lockdown, and it was just this wonderful, peaceful, like such a feels good situation for people who were really trying to escape their lives at that point, which were not feeling good. Yeah. So, yeah. Yeah, interesting. Anyway, so let's see if there are any other questions. Yeah, Hamish was saying it was like 2017, and it was Henry Stickmin was the first person that blew up Among Us. Yeah. Oh, Hamish was saying it got picked up as people going back because the devs released a game afterwards that did better, and people went back to their back catalog, and then it exploded. Yeah, but it's just really interesting. Like, I think that most of the biggest games in the world were not based on their engineering principles being great. There's only a few examples where the engineering was as good as the social impact of the game. Sorry, we just, yeah. If you get me on the history of computer games, we could be here for a very long time. But I'm going to say everything that John Carmack touched. Anyway, I should stop. There is an entire video on my YouTube channel of a talk I gave for CSE Soc. It was meant to be like a 1-hour workshop with a 1-hour Q&A, and I think it turned into a 4-hour talk. But the Q&A was like all the way through it and stuff. But yeah,
with you playing Halo at the end.
I think I streamed Halo at the end. Yeah. Okay. No, Henry Stickmin made the game. Sorry, I haven't gone that close into looking at it. Henry Stickmin is a person, but a fictional person. Right. Okay, sorry. I think I'm missing a lot of the history of this. Like, I've looked at it as a theoretical concept from the outside, but not really being super involved in Among Us. So let me open her up again, just in case there's any technical questions related to COMP1511, because we're now in filler content. So if there's any technical questions related to COMP1511 that people want to know anything about or want us to clarify anything, please let us know now, because we have time scheduled here. We've got like another 40 minutes scheduled, but I'm not necessarily going to just have a hangout and chat stream if we don't necessarily have 1511 questions to answer, because I don't want this to be something where people go to this video to look at for a revision and then they get Mark's repetition of the history of video games. Hamish is like, so Halo streaming.
Wait, Halo isn't on the final exam? Oh, we're gonna have to rewrite it then. Oh no.
Well, I mean, we could definitely write I don't know, like we could write a Halo themed question, but it would be like, I don't know, these weapons in Halo are organized in this array or something. It's like, it would be so contrived. It's really hard to do a first course in programming and first person shooter. Like, there's like the complexity levels of those two pieces of code are just completely different.
One of my favorite things about writing exam questions is getting to write the like theme at the top of like what is going on in this question, especially for the ones that are like a little bit bigger. You get to talk about, like, oh, this crazy thing where, like there are miniatures, but they're not miniature or something. It's a good time.
Yeah. And people are saying that your physics teacher had questions with Star Wars references. I do have Star Wars references, but they haven't come up yet. They're in a later lecture. Tammy, is there anything that has popped up in the forums a lot that a lot of people are asking about that maybe we should
There's also a question
clarify
in chat, by the way.
something? Oh, is there a genuine question now? Yes.
There is a question in the chat.
Okay, we'll go to that in a sec. We'll go to Tammy's thing, and then we'll go to Hussein's question.
Yep.
So there is the one thing was the thing I spoke about before with laser, moving laser and putting it into function.
Right.
So if you're watching this video, then go to the beginning of the video. The other thing is, I think for people who's just starting or like is doing stage 1, they might be struggling with the control D, so getting user input and control D a lot with the assignment. So a really, really, really big hit is your CS calculator lab exercise. And another really, really, really big hit is there's been a lot of discussions on the getting user input onto control D and how do you actually get a variable number of inputs. So in the assignment, sometimes you need one command, a command with only one value. Sometimes you need a command with like 3 values. Sometimes you need a command with 2 values, and so on. So all of that comes from, I think Mark's getting something up on the lecture.
I have a scanf demo that actually does input until Control D.
Yeah.
So these things may help as well.
Yeah.
It's,
So
chapter
especially I think the bottom line, it might be line 70 something, line 60 something. On that page. Yeah. Especially
This one reads up to 10, but this isn't exactly it. So I think it's like, I mean, of course, it's never going to be exactly it. I'm not going to give you the code that you can just copy paste into the assignment. But there's that kind of thing where you go scanf until Control D, and then after that, you know how many the next inputs are going to be. So then you loop a specific number of times after that. That kind of thing, right? It's not exactly that, right? But it's something like that in the assignment. Yeah.
Yeah, so that's like a common hurdle we found. And if you are stuck, go back and revise on the CS calculator exercise. If you're not sure how that one works, there's some explanations on the forum about scanfing until Control D. There's also, like, Mark's explained it in the lectures as well. And if you have any particular questions about the Control D stuff, like, you can ask on the forum and we can help you out, or ask in the help session and stuff. I'm not sure if we want to explain that, like, again here. Do we want to do that, or?
I'm not sure. Where's the calculator? Is that week 4?
Week 4, yeah. Week 4. Are the solutions for that released yet?
Yeah. The solutions should be, or might be released. No. We're only just into week 6. They might be released now.
They should have been released on Monday. If they're not, I can go fix that up. For week 4,
I may not
have
have flicked them over on WebCMS, which means they're technically visible, but we haven't given them a link to them yet. Right.
Yeah.
Oh, yeah. I know this one. This one's like built specifically to be the same kind of input as the assignment, to give you a lot of training in that. You'll note that, like, a lot of the things that are weird, if they're weird in the assignment, we try to make sure that there's something else that shows it to you beforehand. So it's not just, like, coming out of nowhere. Unless you don't do the lab exercises, in which case a great deal of the course is going to come out of nowhere and surprise you. But, I mean, that's like, you know, if you're not doing the work in the course, then it's hard to know what's happening.
Yeah.
Alright, let's see if there were any questions, because there was some... Tawaka's asking you about the extension component marking. Will all the tests be run against each other automatically? That kind of thing.
So it will all happen automatically. There is a small extent to which it will need to be determined after we finish marking, because we need to make sure, for instance, that, like, the marks are sane, and also if there are 500 extension submissions, each with 2 tests, it's going to take us a very long time to run all that marking. So what we've said is basically we will run the marking ourselves. We will run every single test against a subset of submissions. We'll run every single submission against a subset of tests that's sort of representative, and also that gives a sort of reasonable curve of marks, hopefully. And then at the end, we'll write an explanation of exactly how we achieved those marks. And if there are questions or problems with that, then we can address them at that time. That's sort of the plan. So it'll all happen automatically, and at the end, you'll be told exactly how that was done. And it will we're doing it the way we're doing it just to make sure that the marks are reasonable, given that we don't control what tests we're given.
Yeah. I think it's important to note that we can't necessarily test everyone's testing against everyone else's assignments, because that's like a multiplicative thing that will end up being so many tests that we won't finish our testing before, like, assignment 2 is due, and then you don't get your feedback and things like that.
Yeah. Can I also answer Hamish's question? The answer to your question is that you cannot be guaranteed that 1511 reference solution will exist when we're doing the marking. Given that you've just said that, I might in fact make sure that that's not available when we're doing the marking, because that is not the point of this exercise. In fact, I think we restrict any P opening.
We have restrictions on it that says you can't open other programs inside your program. So if
I think
you
it
did,
says that somewhere.
Yeah.
I'm
The
not
the
entirely
assignment
sure.
spec has that. I'm pretty sure it has. Like I know I've written some disclaimer bits in there and stuff like that, and it's also in the not allowed C features. Like you can't use the open function, right? I'm pretty sure that text is in there.
I'm not entirely sure.
Yeah,
but
but
at
don't.
any rate, if
Like-
don't because we will
Yes.
find you and we will
We're
et cetera.
probably yeah. I don't think anyone's ever tried that before. Like running a C function that opens another program, opening 1511 solution, and then running the inputs and outputs out of there. I actually don't know if anyone's ever tried that because they wouldn't have gotten like full marks, or we wouldn't have noticed. Actually, we
Put
would
it
have
this way,
noticed. Someone would have style checked it and just gone, "Hey, what is that?"
we would have noticed. And
It's like,
and more
why does
importantly,
this student's perfect marks program only have one line in it?
yeah. Yes, and also relevant to note, you don't have to agree to the good faith policy in this course, but in security courses, they have this thing called the good faith policy, which is basically like, even if you're doing something that is not against the law, it's not good enough to just not break the law. It's also important that you do things in good faith, i.e. trying to do things like cheat. Well, cheat is a strong word. Manipulate the system such that your answers are just using our code is probably against the good faith policy and is probably not a good idea. And we will attempt to stop you from doing that sort of thing, because it really isn't teaching you anything inside the course, so it's not really sensible for us to let you do that.
I think
Similarly,
it's always the case is like if you didn't learn anything from it, then it's probably not the right thing to do.
yes. Similarly, attempts to do fun things with like, trying to mess around with course infrastructure. Again, very, very fast way for us to have a long conversation with you. So like, please don't go, messing around and be like, oh, I wonder what happens if I send malformed packets to this thing. Am I going to be able to like break into, whatever? Please just don't do that. Please don't.
But if you do that and it works, can you let us know so that we can patch it?
Yeah, the issue is that we'd prefer for it not to happen in the first place because it's technically a violation of both the law and UNSW policy, and it's just complicated.
Things get really
there are actually stories about like people who, for instance, have hacked Apple or Google, and they thought, I'm going to tell them that I hacked them, and Google are going to like give me a job, and then Google like sent them a message being like, we want to give you a job. They came to the States, and as soon as they stepped foot in the United States, they were arrested for computer fraud. Because like, yeah, so not that we're going to send in the police if you, p-open 1511 slide reference, but please don't do that.
I think Hamish is now quaking in his boot. We've just escalated this way beyond what
Sorry.
we'd originally been asking.
No. It's, no. To be clear, not allowed. You can't be guaranteed that it'll work, but you're not going to get in trouble for it, certainly.
Yeah.
I'd probably laugh quite hard if somebody did that. You would get a chuckle from me.
Yes. I do appreciate... Because I've literally caught someone with, like, an exam with code written on their leg. And it was really funny because I think it was in winter and they were the only person, like, wearing shorts. And I was like, what's going on there? Like, do you remember that? I don't know if you remember that person, but it was so funny. It was just like, oh, come on. Whereas this level of, like, not really cheating, but the manipulation of the assignment stuff, I think is quite interesting. Because you're actually going, ooh, what can we do with C that there's interesting ramifications? So I think it's interesting to talk about, as opposed to like just blatant cheating, which is very boring. But I think interesting use of infrastructure and stuff, I think, is always really cool.
Yep.
Xenocide was saying
There was...
there are ways to do... I think Xenocide was in good faith saying there's no reason to use popen because you can pipe things to and from and stuff. I think Xenocide is actually is answering the question in good faith. And it's like, you don't need to use popen to get the reference. But I think it was just because Hamish was being a bit facetious and going, what if I use popen and use its output as my output and stuff? Whereas Xenocide saying you can just pipe things in and out. Using the instructions we have in the assignment spec to do things.
If you want to go and learn what not to do, you could just use execve as well. But anyway,
I think that's
there was an actual question from Hussein.
Hussein had a real question.
That was a real question. The style guide doesn't have much info on this, but is there anything against indenting consecutive lines of comments?
Let me see if I understand what you're saying. If we're indenting consecutive lines, as in, if I did something like, I just tabbed that twice here, like this kind of thing where I say this is all one comment, and this continues on from this. I think the only thing that we have to do is, like, when you start the line, make sure that's at the code indentation so that we can see what is contained within which set of curly brackets and stuff. But if you want to do more formatting inside here to imply that this is all one comment, and then if I have another comment here it's separated, you can do that if you want. Just don't necessarily do different indentation with the slashes if you're going to use them, because they should, like so, be kept at the right level. But this actually looks quite good. I didn't think about it, but this makes it really clear that this is one comment and this is another. So I'd not done that before, but like I actually see how like it does actually make sense to do that.
Can I ask Tammy the other question?
Yes.
Tammy, if we pass all auto tests, will we get all the marks of the functionality, or is there more to the functional marking than that?
If you pass all the tests we give you, there is way more to that. Way more. We don't. So it's essentially, even if you pass all the auto tests that you see, it doesn't guarantee you getting full marks. In fact, a lot of times you will need to do a lot of your own testing, because we use a different set of tests to test your assignment against in our auto marking, and that's part of what we're assessing you on, because we want you to be able to think about what kind of inputs, what kind of edge cases, what kind of scenarios can happen when a user uses your program. So to directly answer your questions, you will not necessarily get all the marks for functionality if you pass all the auto tests given to you. Yes.
The thing I'd add to that as well, entirely, Tammy is entirely right. The only thing I'd say as well is just like, generally for the early stage of the assignments, we're not trying to trick you with the auto test inputs, but it's more just a situation like, let's say that we give you the input like 1616, as you know, you need to put a block at 1616, and your program says, no, you can't do that. That's not allowed. We might test you, we might like auto mark you on the input, 1317, which is a different input. It's the same idea of like, it's not valid, but it's a very slightly different input. And so sometimes what can happen is like, we'll give you a test that is the same, different. And so if you haven't accounted for that, you might lose some marks. But overall, passing all the auto tests is a pretty good indication that you've gotten all the major things that you needed to get.
That's in the early stages.
That's in the early stages. If we ever say like we've intentionally not put in tests, or like for the extension stuff where we're trying to get you to play into this, or like extension lab activities, then we'll start, deliberately leaving things out. That probably will happen in the exam as well. As, like for the last question or last two questions, we say, here are some test cases, but you might need your own too.
So I'm just giving you an example here where we might say 1616 auto test and it's off the edge, and then the marking test might be over here. So we might not necessarily auto test you on this direction. We might auto test you on these two directions, but you should know at that point that it's that we're going to test you somewhere outside the bounds to make sure that you're dealing with it. Little things like that. So you can see, and also there's also the what I'm going to call the Hamish solution to this now, where if you want to, you can read what all of the auto tests do. So you can read the inputs and the outputs, all the auto tests, and you can put a bunch of if statements in that just says, if the input was this sequence of numbers, my output should be this grid. And obviously you could pass all of the auto tests that way and fail every single one of the marking tests. So remember the purpose of the program, not just the inputs and outputs. Sorry, Hamish.
That's why we have marking tests.
I'm now going to use you as the example of gaming the solutions.
Hamish, you'd probably enjoy COMP1511, which is the security course, which talks a lot more about messing with things like that.
Yeah.
So
Um,
you may have a talent for it.
Hussein was asking about doing indentation using the what are they called? The comment ends.
Block comments.
Block comments. Yeah, using the block comment
That's
ends.
the problem.
Wondering whether the close of the block comment needs to be on a new line. I would tend to put it on a new line just because it's easier to see where things start and finish if they're closer to the left-hand side on your screen, left-hand side. Yeah, rather than putting it on the end of a line, it's harder to see. So yes, I would do what you're saying, Hussein, and treat it a bit like a bracket. Having said that, the comments are not as necessary to be like perfect style for those things because it's really clear because they get colored in with different colors, but I would still potentially do it so it was like, really visible. You're not really going to lose style marks over where the closing the block comment is. Hamish, decompiling the 1511 binary, extracting the reference implementation. I think it could technically work, but I mean the code would be horrendous. Any decompiled code, you tend to because in the compilation process, the computer makes a whole lot of shortcuts to get the code running more efficiently, and they're things that make it very, very hard to read. And then when you decompile it, you'll find that there's only one array in your entire program, and then everything else is just pointers to parts of the array and stuff. I don't know if that's not the only thing that happens when you decompile, but it's one of the things. And it's all of your memory management just goes out the window, and all your variables don't exist. They're all just addresses into this one giant array, and it won't be an array of integers either. It'll be an array of characters, and then certain chunks of it will be used, and it's just it's a mess. So, as Tom said, please don't.
we go to a bit of effort to make sure that it's not just trivial to decompile the reference solution. There are some interesting things that we do to make sure that you can't just copy paste.
Yeah. Although Xenocide has a point there that DCC's compiled programs.
That was one of the things which I was mentioning, that we make an effort to not just, let me open the program and there's the entire full compiled program.
Yeah, I was going to say though, DCC, if you can figure out how DCC works and how it all goes together to show you the stack traces and the and where in your code, line by line, where in your code it's up to and stuff like that, I would be happy to give a rubber stamp to anyone who can do that and say you don't need to do 1511. Because you're already at third level compilers, specialist, student level of programming if you can do that. Because DCC, how many different compilers is DCC using? It's using 3 compilers and a different debugger, right?
Yeah.
And 2 different debugging tools at once. Because it's using Valgrind and GDB at the same time, right? Yeah.
Yes.
There's so much stuff in it. And as a professional computer scientist, you will learn all of these tools eventually. But to be able to combine them all into something that looks like a single compiler is, it's a pretty advanced level of doing things. It's all done
DCC
by Andrew
is
Taylor,
kind of incredible.
Actually.
Yeah,
he's another lecturer.
It's an amazing system.
Sorry,
I was just saying DCC is an amazing system.
Yeah.
The amount of different things going on that you don't see that are there's you're not actually, when it turns out that when you run a program compiled with DCC, you're not actually running a C program initially. You're running something else that then starts 2 C programs at the same time and runs them both and checks whether there's a bunch of fun stuff that goes on.
Yeah.
So
it's epic. It's epic. The source code for DCC is available.
I think so. Yeah.
Andrew Taylor has it publicly available on his GitHub, which is how you can install it on a Linux computer if you want to.
Yep. github.com/comp1511unsw/DCC.
Yeah. The only downside is actually understanding it. I haven't even poked into it. I just have a broad brushstrokes idea of what it does, and I'm going to trust you with it, Andrew. I have other things to do rather than spend 6 months trying to figure out your super custom compiler that you've been building for the last 10 years. Yeah. Yeah, Hamish was saying that it has some Clang in it. Yes, and it does have some Clang in it. Clang is, I don't know, which is 20% of what DCC does, I think, is Clang. And it's got all this other crazy stuff going on in there. Yeah. I don't want to dig too much anymore into it.
Yeah.
Yeah. Okay, let's. I'm just gonna put out a final call for any questions anyone has about 1511 stuff, and I think if we're out of questions, we will wrap it up there. Because I think now we've really kind of we've gone on several tangents now, and I think that's a sign that that it's not necessarily specific code questions that we're getting right now, or specific 1511 style questions or anything. Not 1511 style, but 1511 ish. There's so many words you can't necessarily say in this subject because they all have specific meanings. It's good. It's good. It's like learning about programming. Like you understand that there are certain words that will trigger an entire sequence of code events if you use them. Hussein's asking, when do the help sessions pop up on Hopper? They should appear pretty much exactly the time the help session starts. It's really basically the first tutor that gets into the help session will start the Hopper session. So if you're there on the dot, you should be able to get in pretty much immediately. Although there's a queuing system so that if we had a situation where we couldn't help someone the previous day, then they get to go to the front of the queue. We're actually, like, we noticed last night that there was like a lot of demand at the moment for the help session, so we've thrown a few more tutors at it. So hopefully it'll get, well, I say hopefully the queues will get shorter, but I don't think the queues are going to get shorter because more people are going to join them. So we're
yeah. This is sort of, unfortunately, there's not much we can do about the fact that, like, you know, we'll get 100 students who turn up to a help session, and we'll try and have lots of tutors there, but it's very difficult for us to predict demand and to schedule that many tutors within that same period. And so to Hussein's question, there's no pre-booking for a help session. It's you join the queue and you wait, because there's really no better way for us to do the allocation of tutors to students, unfortunately.
So I think the only thing is that we can say that we now have a bunch of reserves tutors to drop in at a moment's notice if the tutors who are in the help session have kind of let us know that it's getting too busy. So we've already kind of figured out who's available in the next help session times, and so hopefully if demand gets high, we'll be able to meet it by just throwing more bodies in, more tutors in to try to help. Yeah. Okay.
More quicker questions, like smaller questions, or questions that you think you can get answers. Like if you're like not completely stuck or something like that, you can always ask on the course forum, and we can always look at your code on the course forum as well. It's just it will take longer for us to get to people who are asking us to directly read your code. So if you can describe your problem without having tutor to look at your code on the course forum, we can help you out much quicker there as well. But yeah, that's just another way you can reach out for help if the help sessions are taking way too long for you because there's such a high demand there.
Hamish had another unrelated, but we can answer it anyway, question. Asking you about recommendations already, courses for web dev. I think there is one particular... What's the course code for the front-end dev course? Is it 69?
COMP1511.
6080.
Front-end web dev.
6080. That's the one that's a specifically front-end web development course.
Yep.
I think that would be a good one for front-end. I think for...
I would also recommend COMP1531 and 2041. Don't focus on the front-end, but are very useful, I would say, for front-end.
I think you don't really have a choice on those two. Oh no, 2041's not core.
2041 you have a choice about.
Yeah.
The other one is, I suppose that those two are much more back end, but they're really useful for that. I'd also recommend, sorry to keep recommending things, COMP3511 as well.
I was about to say, yeah, for the theory of front end. Yeah.
Sure, I'll put that in the chat. Yeah.
Hussein was, is there a penalty for karma farming on the CSE SOC Discord? I think whatever goes on in the CSE SOC Discord is a CSE SOC issue, and it won't have anything to do with 1511. I mean, like, technically I am on that Discord, but the amount of time I have to spare. I think since 1511 started as a course and people started getting really active in the 1511 channel, I haven't been able to keep up with it because I think that's like there's a lot of conversations going on there. So I've just sort of let people go, and it's like you can have your conversations there, and you don't necessarily need me poking into them. So Xenocide said, ask Michael what his penalty was. So there was someone was farming for karma on the CSCSOC Discord, and then something happened. Who knows what? Yeah. Stray turned off Michael's rep. That's pretty funny. I think having rivalries between the two CSCSOC co-presidents is a very funny thing to have happen. Okay, so I think we'll wrap it up there. Thank you everyone for coming along. Hopefully, I guess in the first half than the second half. Second half was just a general discussion, but hopefully there's some stuff that helps people with 1511 and gives people some information to be able to kind of understand some of the topics that we're teaching more. And you've had a little bit of a chat with two of the tutors here as well. I mean, especially if they're not your tutors. So, Hussein said, you now have more karma than me, but got warned by Shrey to stop. Yeah, I think there was a point where I was only doing stuff if people would thank me for it, so that I would get rep. Alright, we're gonna wrap it up there. See you later all. Bye Tom, bye Tammy.
See ya.
Thank you for coming along.
Thank you.
Alright. Bye everyone.